Glycolysis and glycogenolysis are similar because their goal is both to resynthesize ATP, but they break down different molecules in order to achieve that. So glycolysis breaks down glucose, while glycogenolysis breaks down glycogen. Glycolysis can only occur in the muscle, but glycogenolysis can occur in the muscle or the liver. But for this question, we're going to focus on when it happens in the muscle. So they're both a series of 10 steps where one molecule is converted into another molecule. And the 10th step is where we get to pyruvates. And these 10 steps can be broken down into 3 stages. So the first stage is steps 1 through 3, where we call it energy investment, which is where ATP is invested or used. And then we have the splitting stage, which is steps 4 through 5, where one 6-carbon molecule is broken down into 2 3-carbon molecules. And then steps 6 through 10 is the energy generating phase, where ATP is formed or generated. So energy investment, which is the first stage, is kind of where these two differ. So in glycolysis, the first step is when you use glucose, which is a 6-carbon molecule. And that glucose, in order to be converted into glucose 6-phosphate, requires an ATP molecule to be dephosphorylated into ADP. However, in glycogenolysis, in the muscle, that first step requires glucose and glycogen, and glucose, again, requires the ATP to be dephosphorylated into ADP, but the glycogen doesn't require any ATP in order to be converted into that glucose 6-phosphate. So because it doesn't require another ATP molecule, you get a net gain of 3 ATP in the muscle for glycogenolysis, and in the glycolysis, you get a net gain of 2 ATP, and both result in a net gain of 2 NADH plus H plus.